Hey guys, so today we're going to do integration, part 1, just the basics. So integration is basically just finding the area under a curve. And we'll go more in detail later on in the video. So let's start with this. Basic power rule. You guys should remember the power rule from derivatives, right? So dx dy of 3x would just be 3, right? Power rule. Now, there's a different power rule for integrals. Okay, so I'll use blue. So this long little s thing, that's an integral. So the integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c. We'll talk about that plus c later. Let's focus on this part. X to the n plus 1 over n plus 1. So what that means is if I have x cubed dx, this would equal x to the 3 plus 1 over 3 plus 1, or x to the 4th over 4 plus c. Alright, so what even is this plus c? Well, I wrote down some derivatives here. The derivative of 3 is 0, and the derivative of 300,000 is also 0. So we add the plus c, because when we're going backwards, we don't know what that extra constant we're integrating. It could be anything. So that extra constant gets lumped into c. So plus c basically means I don't know what constant was lost when I was differentiating, but it could be anything. It could be 1 or it could be 1 billion. So we add up plus c to cover all our bases. Now, let's do some examples. The integral of 3x squared dx. Now, similar to derivatives, we can pull out a constant. So what does that mean? Well, this would be the integral of x squared dx. We just pulled out that 3. Now, let's use our power rule. 3 times x to the 2 plus 1 over 2 plus 1 plus c. You're going to get points off if you don't remember the plus c. Which is 3x cubed over 3 plus c, which is just these cancel, x cubed plus c. Great. Now let's work on our next one. Integral of x dx. Okay, well, this is x to the 1, right? We don't need to write that though. X plus 1, 1 plus 1. This is x to the 2 over 2 plus c. So eventually you're not going to need to write this plus 1 plus 1 over 1 plus 1 every single time. You're going to become a pro at it. But for now, we're just walking through the steps. Now, next one. Integral of 3 dx. Okay, well, I don't really see an x. So how can I use my power rule? Well, let's think about it like this. The integral of 3 is the same thing as the integral of 3x to the 0 dx, right? Because what is x to the 0? I'll write it in blue up here, right here. X to the 0 is just 1, right? Anything to the 0 power is 1. Now, I can use power rule, but first let me pull out this 3. I don't need it. 3 to the x 0 dx. Let's use power rule. 3 to the x 0 plus 1 over 0 plus 1 dx equals 3 to the x over 1. Oops. 3 to the x over 1, which is just 3x, plus c. So, boom. So, what do you notice? When you integrate a constant, you're just attacking on an x, right? Because think of integrals and derivatives as opposites of each other. If we take the derivative of 3x, we're going to get 3, right? Because we're finding the slope of that line. The slope of 3x is 3. So the integral of 3 is going to be 3x. It's just opposites. And remember, plus c, like this is, I lost a lot of points because I forgot plus c almost every single time. So remember that. Now, definite integrals. So far, we had indefinite integrals. This is definite integrals. So like I was saying before, integrals are just the area under a curve, right? So the integral of here, let me write it in pink. The integral of x dx would be this shaded thing in pink right here. It's just the area under y equals x. Now, what does this over here mean? Well, this says integral with bounds a to b of f of x dx. Okay? That's a definite integral. The only difference between a definite and indefinite are the bounds. The definite integral has bounds. And what do these bounds mean? Well, the bounds are basically telling you where you're finding the area. So you're finding the area from x equals a to x equals b. Okay, so it's saying only calculate the area under the curve between those two x values. Next problem, we'll go into more detail on how we actually solve it, but just remember, okay? X equals a, x equals b. We're solving the area under the curve between those two x values. Alright. Okay, so here's the same graph. We're solving integral from 0 to 4, right? So the x of 0 to 4 of x dx. Well, this is a line dx, the same graph as before, and we're trying to find this area right here from 0 to 4. Now, let's do it without calculus, right? So the length right here, oops, let me just use yellow. The length right here is 4, right? And the length from up here is 4. So we know the area of a triangle, right? 1/2 base times height, 1/2 4 times 4. This is just 8. So right now we know that this pink area is 8. Let's use calculus now, because not all shapes are going to be easy triangle, even though I wish it was. So integral 0 to 4. Now, same steps as before as the indefinite integral, right? It's going to be x to the 1 plus 1 over 1 plus 1 equals x squared over 2. So it'd be x squared over 2. Now, a lot of people have different notations for it. I like to make it little brackets like this. 4 to 0. Okay? So now we're going to substitute these values in, okay? So 4 squared over 2 minus 0 squared over 2. So what you're doing is basically you're subtracting the y values of the integral at the bounds. Okay? So we're plugging this in first. We get that. And then we plug this in. We get this. So let's solve that. So we get 16 over 2 minus 0 over 2 is just 0. We get 8. And that matches up with our 8 up here, which is great. Alright, so let's try a little bit more. More definite integrals. Integral 0 to 2, 2x dx. Alright, so pause the video, try to figure it out yourself. First step for me is I'd pull out the constant. So now I have x squared over 2 to 0. And then I'd cancel out these. So I just get x squared to 0. And how did I get x squared over 2? Well, this is just x plus 1. 1 plus 1, sorry, over 1 plus 1, which is x squared over 2. Now we do the same. We put this in here. 2 squared minus 0 squared. So we plug in that it's the top bound minus the bottom bound. So this is just 4 minus 0, which is 4. And boom. That's our answer. What does this 4 even mean? Well, it means on the line, pretend this line is 2x. From 0 to 2, this pink area is 4. Okay? That's all that 4 means. Let's move on to the next one. Okay. Integral 0 to 3 of 3x squared plus 2x dx. Now, this is a little bit trickier, but we can still do it. Same thing with derivatives. You can distribute almost the derivative, right? So we take the integral of 3x squared, just be 3x cubed over 3 plus 2x squared over 2 with bounds 3 to 0. I'm going to cancel these out to make it a little bit easier for myself. 3 to 0. Now, same steps, plug these in. So 3 cubed plus 3 squared minus 0 cubed plus 0 squared. And this would be 27 plus 9 minus, this is just 0. So 27 plus 9 is 36. My answer is 36. And so if I were to graph this, the area from 0 to 3 would be 36. So these are the must-know integrals you guys are going to need to memorize to get a good score on the AP exam. There are a lot of cheat sheets online, but these are the ones I want you guys to memorize for the next video, where we're going to be talking about U substitution, kind of a sneak peek, U substitution. But today's video was more of a basics. If you knew nothing about integration, I think this was a good place to start. If you have any questions, leave them in the comments. But in the next videos, we're going to go a little bit more in depth, and eventually by the end of this integration series, you're going to need to know everything you need in calc AB and BC. So thank you guys so much for watching. I hope you guys have a good day, and I'll see you in the next one.